All right, in this video, section 1.2, our goal by the end of this lesson or the end of the assignment is that you can solve multi-step equations with a one known variable. Before we did one-step equations, now we're throwing in multi-step equations. A couple things to review real quickly. An expression, recall, can be numbers, variables, constants, or a combination of those. So here's a basic example of an expression. Notice it doesn't just have to include the variable x, it can include any variable there. Include plus signs, minus signs, anything like that. An equation is just two expressions separated by an equal sign. That's the key for something to be an equation. The word equal sounds almost exactly like an equation, so that's an easy way to remember that. An equation is just two expressions separated by an equal sign. The solution is just a numerical value for the variable that makes the equation true. That's what we're going to be hunting in this video. And then finally, maybe most importantly, to determine the solution, we're using inverse operations. Inverse operations, operations that undo other operations to isolate the variable. It's the variable in the problems that we want to isolate. So let's do one example problem here. Keeping in mind, I've got the steps outlined here. And essentially what we're doing is we're following at the beginning of this problem, the beginning of these steps, we're going to follow PEMDAS, order of operations. We're going to distribute to eliminate parentheses first. Of course, that's the first part of PEMDAS. We're going to combine like terms on each side. Those first two steps, really these first two steps, that's not algebra. This is just arithmetic that you've done in all of your previous years of math. Steps 3, 4, and 5, that's when we get into the algebra because we'll be using inverse operations. But let's go and tackle this problem. 27 equals 6 multiplied by the quantity of x plus 2, all of that in the parentheses, and then a plus 3 tacked on at the end. So first step, we are going to distribute to eliminate parentheses. So we're going to take the 6 and we're going to multiply it by the 1x. 6 multiplied by 1x is just 6x. 6 multiplied by a positive 2 is positive 12. Notice we don't distribute the 6 to the 3 because the 3 is not on the inside of the parentheses. So I'm just going to bring down the positive 3. Didn't do anything to the 27 on the left-hand side. So that's step 1. We've eliminated parentheses. That's really what we were after here, eliminating the parentheses. Step 2, combine like terms on each side. So obviously when we say each side, remember we're talking about each side of this vertical line that we can divide right through the equal sign. So the left side, there's only a 27. So there's no like terms on the left side since there's only one term. On the right side, our like terms are positive 12 and positive 3. These terms do not have x's with them. So we can just add those together like we always would. Positive 12 plus 3 gives us positive 15. Notice we don't have to subtract 3. We don't have to do inverse operations yet because, again, the 12 and the 3, they're on the same side with one another. So now we don't have any like terms on the left side or the right side, so we've completed step 2. Step 3, move variables to one side using inverse operations. So the key word here in step 3 is variables, plural. I only see one variable in this entire problem. So we don't have variables on the right side and the left side, so we can go ahead and skip step 3 because we only have one variable in this problem. Step 4, move constants to the other side opposite from the variable. So that means we want the 6x to be stationary. In fact, what I'm going to go and do is I'm going to go in the next step. I'm going to write the 6x right there because I know that's not going to move. That's going to remain stationary. What needs to move is the constant that's on the same side with the 6x. So the positive, remember our goal is to isolate the variable. That means get the variable by itself. So to do that in this problem, we're going to do inverse operation of plus 15 and subtract 15 from both sides. 15 at minus 15 is just 0. I'm going to erase that because we don't need to write plus 0. Covered that in the last video. 27 minus 15 is 12. So that's step 4. The constants are all on the other side away from the variable. And then finally, step 5, multiply or divide to eliminate the coefficient. So remember, 6x, that really means 6 multiplied by x. So the inverse operation of multiplying x by 6 is dividing x by 6. Whatever we do to one side, we must do to the other. 6 divided by 6, anything divided by itself is just 1. We talked about this in the last video. We don't need to write the 1. So I'm going to erase it. On the other side, 12 divided by 6 is positive 2. Let's go back and just double check our answer. So I'm going to rewrite the original problem. The only difference is instead of writing x plus 2, I'm going to replace x with our solution, which was positive 2. Then we do the math. On the inside of the parentheses, 2 plus 2 is 4. 6 multiplied by 4 is 24. And 24 plus 3 is 27. So that checks out. Other examples, solving equations using inverse operations. So again, we want to follow the steps outlined above here. And every once in a while, there's going to be variations to these steps, but generally these 5 steps will serve you well for the majority of the problems we see. So there's no parentheses, so we can skip step 1. Step 2 says combine like terms on each side. Well, the right side only has 1 term, so nothing to combine there. The left side has 2 terms, but one of those terms has an x and one of those doesn't. So there are no like terms in this problem. So step 2, we can check that off. Step 3, move variables to one side using inverse operations. Again, keyword variables, we only have one variable in this problem. It's 3x. So again, we can skip this step. Step 4, move constants to the other side, opposite from the variable. So there's only one constant, there's one constant on the left, one constant on the right. We need to do the inverse operation of subtract 2. Because our goal is to get the variable by itself, and we want to move the constants to the other side. So we end up, I'm going to bring down the 3x. Negative 2 plus 2 is just 0. Remember, we don't need to write that, so I'm going to erase it. And on the right side, 6 plus 2 is 8. So that's step 4. And then finally, step 5, multiply or divide to eliminate the coefficient in front of the x term. So remember, this is 3 multiplied by x. So the inverse operation is we're going to divide both sides by 3. 3 divided by 3 is just 1. So that's 1x. We do not need to write the 1. On the right side, 8 divided by 3, we could stick this in the calculator. 3 doesn't go into 8 evenly, so we could just write our answer as 8 over 3. Or if the answer called for a decimal, this would be 2.67. Example 2, x divided by 2 plus 4 equals 10. So again, we can skip step 1. There's no parentheses. Step 2, we can also skip because there's no like terms on each side. This side right here, one term is a positive 4. The other term involves an x. So we can skip that step. We can skip step 3. There's only one variable in the problem, so we don't need to move variables to one side using inverse operations. So that leaves us to step 4. move constants to the other side. So that positive 4, we need to do the inverse operation of adding 4 and subtract it to move it away to the other side, away from the variable. So this leaves us with x divided by 2 equals 6. 4 minus 4 is 0, so I'm going to cross that out. 10 minus 4 is 6. So that's step 4. Step 5, multiply or divide to eliminate the coefficient. So in this problem, we are dividing x by 2. So we need to do the inverse operation and multiply both sides by 2. So we're going to multiply this numerator by 2. So this gives us 2x, 2 multiplied by x divided by 2 equals 12. Well, what is 2 divided by 2? It's just 1. And of course, we don't need to write the 1. There's our answer. X equals 12. Example 3. So let's go through the steps. Step 1, distribute to eliminate parentheses. We do have parentheses, so we need to distribute the negative 3. Negative 3 multiplied by 7 is negative 21, and negative 3 times a negative 2x is a positive 6x. Negative times a negative gives us a positive. So that is step 1, distribute to eliminate parentheses. Step 2, combine like terms on each side. There are no like terms on the left side. There's a constant and then a term with an x. So we can skip step 2. Step 3, move variables to one side. There's only one variable, so we can skip step 3. Step 4, move constants to the other side, opposite from the variable. So that means we need to leave the 6x alone and do the inverse operation. Tricky here because we see negative 21 plus 6x. But really, we could rewrite this as 6x minus 21. Really, we are subtracting 21 in this problem. I'm not going to rewrite it that way in this problem, but I want you to see that really we are subtracting 21 even though there's a positive sign here. So the inverse operation of a negative 21 is a positive 21, and we're going to do that to both sides of that equal sign. Negative 21 plus 21 is 0. We're going to bring down the positive 6x. 5 plus 21 is 26. And then so finally, that's step 4. Step 5, multiply or divide to eliminate the coefficient. The coefficient is 6. That is 6 multiplied by x. So we're going to divide both sides by 6. 6 divided by 6 is 1x. And then 26 divided by 6, that's going to be a decimal, so I'm just going to leave that as a fraction. I could reduce that because both those numbers are divisible by 2. So this could be reduced to 13 thirds. So 13 thirds is our answer. If you wanted to convert that to a decimal, I believe that's 4.3 repeating. Number 4. So this one's going to challenge our steps. Step 1, distribute to eliminate the parentheses. So the tricky thing here is there's no number in the front of those parentheses, so there's assumed to be 1. So really they've just put those parentheses there to tell you that you're dividing all of 5 minus x by 2. So there's nothing really to distribute, so we can drop the parentheses. Step 2 is combine like terms on each side. So again, there's no like terms because we have a 5 minus x over here. So one's a constant, one's a variable. So we can skip step 2. Step 3 says move variables to one side. We can skip that step. There's only one variable. Step 4, move constants to the other side, opposite from the variable. So at this point, you might be thinking, okay, in the past, what I've done is I've subtracted 5 from both sides has been my next step. But really, what would make this a lot easier is to eliminate that fraction. Because if we think about this, what we have is we have two fractions. We have 5 over 2 minus x over 2. They've just rewritten this problem right here. Instead of writing as two fractions, they've written it as one fraction. So what we want to do here, instead of, and we don't really want to split it into two fractions because that's going to get messy too, is let's get rid of the fraction. The fraction makes this a lot more complicated. So what we can do, instead of dividing by 2, we're going to multiply both sides by 2. So normally that's the last step, but in this case, since we're dividing multiple terms by 2, we're going to get rid of that divisor right off the bat. So then what happens is we have a 2 being multiplied by all of 5 minus x, but all of 5 minus x is also being divided by 2. So rather than distribute that 2, let's just divide it out, because we know 2 divided by 2 is just 1. And like always, we could write that 1 out front, but we don't need to. Mature mathematicians know there's an assumed 1 in front of that 5 minus x. And on the right side, we get 8 multiplied by 2 gives us 16. Our next step, now we want to move this. This is a positive 5. Don't get tricked by this negative symbol here in front of the x. The 5 is being added to the negative x. So the inverse operation here is we're going to subtract 5 from that positive 5, and we're going to subtract 5 from 16. 5 minus 5 just gives us 0. We're going to bring down our negative x, and that's going to be 16 minus 5 gives us 11. Mature mathematicians know at this point this is a negative 1 multiplied by x equals 11. Our goal is to solve for x. So we have one additional step, and it is to divide both sides by negative 1. Negative 1 divided by negative 1. A negative divided by negative is a positive. So negative 1 divided by negative 1 is a positive 1x. Don't need to write the positive 1. 11 divided by negative 1 is negative 11.